The PLP program. Today we're looking at algebraic equations. In an equation such as a linear equation, we have x plus 3 is equal to 27. Linear meaning there is no exponent higher than 1 over here. Now an equation is like a scale. You will have on your left hand side the balance, or a scale. On your left hand side you have the one part, and then in the middle the balance is the equal sign, and on the right hand side. So in a balance, if you want to maintain balance, you need to know that what you do on the left hand side, you must do on the right hand side. So if I place something on the left hand side, I must place that same thing on the right hand side, otherwise there will be no balance. Now the same as in a balance, we apply that to an equation. So we'll have on our left hand side the x plus 3 in my example, the equal sign, and then on the right hand side we'll have a 27. So our aim here is to make x stand alone, solve x by making it stand alone. So in this case we are going to say, in order for us to move or make the x stand alone, otherwise get rid of the 3, we need to add a negative 3, and that negative 3 and positive 3 will give me 0. But what I do on the left hand side, I must do on the right hand side. So because I subtracted 3 or negative 3 on the left hand side, I must do the same on the right hand side. So it's going to be 27 also minus 3 on the right hand side. So minus 3 and plus 3 on the left hand side will give me 0, x will remain, and 27 minus 3 will give me 24. So we've solved x is equal to 24. In the next example, I've got 2x over 3 is equal to 6. Again, the 3 at the bottom here needs to be removed in order to get x alone, but it is being divided, so I need to multiply by 3 in order to get that 3 at the bottom away. When I do on the left hand side, I must do on the right hand side. So 6 is actually times 3 over 1, so 6 times 3, and when I multiply out the 2 3's will cancel, I'm left with 2x on the one side, and the 6 and the times the 3 will give me the 18. Now I must get rid of the 2 here, divide by 2 in order to make x appear alone. So I'll divide by 2 on the right hand side, and 18 divided by 2 is equal to 9. There's another method of solving equations. Besides now doing on the left hand side and right hand side, we can also isolate x by moving terms from x away from it, and when we move terms we will change the calculation, not change the sign but the calculation. In my example, I've got x over 3 minus 16 is equal to 2. So the first number or the first term that needs to move away from x, we want to isolate x, is the 16, negative 16. So I'm going to move him over to the right hand side, and as I said, moving means changing the calculation. So it's going to be that minus 6 must go over and become a plus 16. So x over 3 on the left hand side is equal to, when I move now the 16, it becomes plus 16, changing the calculation. So 2 plus 8, 16 will give me 18. Then there's the 3 on the left hand side that has to move, and the calculation is division. So when I move it, it must change to multiplication. So when I move the 3, it will be 18 times 3, and that will give me an answer of 54. X is equal to 54. Here I've got a 3x minus 1 divided by a 4 plus a 5. The first thing that has to move away from x is the plus 5. When I move him over, it will become minus 5. So naught minus 5 is minus 5. Then there's the 4 that has to move here. The 4 is divided. So when I move the 4, it must become multiplication. Minus 5 times 4 will give me a minus 20. Then the 1 will have to move, and that 1 will become a plus 1 when it moves. So I've got 3x minus 20 plus 1. That of course now will give me a 19, and when I have to move the 3 now, the 3 is multiplied on the left hand side. When I move it, it must be dividing. 3 divided by 19, and that would be the value of x is equal to negative 19 over 3. You try this now. Here's your exercise, quite a number of them, and you must try to solve for x or the value that is given there in the problem.